Let's review. How do we know if something is included, excluded? What notation do we use with interval notation to say that this number is part of what we're talking about? Parentheses is included or excluded? Or is it excluded? Or is it included? Bracket is included. Okay, so our brackets included, soft parentheses excluded. When we look at a graph and we see a point, how are we going to know whether that point is included in the graph or excluded from the graph? Dots. Included is solid or open? Included is solid, excluded is open. If we're looking at an actual, like a line or a curve, included portions would be solid, excluded portions would have dashes. This was the part that people weren't super familiar with. Have you ever used something that looks like this in interval notation before? Does anybody know the proper name for those things? Squiggles is what I've been getting all day. I call them sideways mustaches. Anyways, curly brackets. This is for discrete values. This would be like, we're not talking about like a range of numbers, like all the numbers between 2 and 3. We're talking about just 2 and just 3. And when we have a situation like that, we put them in these curly braces and we list them with commas in between. So like if you had an equation and the solution was 2 and 4 and 7, you would write that in that way. Probably a lot of your some of your practice worksheets from Algebra 2, you know, that CUDA software, you probably got a bunch of those for practice worksheets last year, maybe not. They always included their answers in that format. All right, we'll see how that comes up here in a minute. Don't worry, if this is the only thing that's new to you today, then you'll find it easy. All right, so we are going to look at some graphs. We got a couple things going on here. We'll be talking about interval notation and practicing with that. We also are going to be talking about function notation and analyzing graphs as compared to 0. So, sorry, give me a second here. Couple things that may be useful to you here if you got any colored pens or pencils. I'm going to do a little color coding, and I'm also going to have a I'm just going to use a post-it note, but if you've got like a small card or another sheet of paper or something, what I'm going to do is I'm going to use this to cover up portions of the graph. So I'm going to show you a couple strategies that might make this a little bit easier for you if you're struggling. All right, so I'm going to go ahead and color code. I'm a visual type person. As you look through here, our goal here is to find all of the x values that are on this graph that satisfy the conditions that I'm giving here. And there's 6 different conditions that you'll see on there. What do you notice about the conditions? What are we comparing f of x to in each of these cases? We're comparing it to 0. And so we'll kind of keep it easy. We're talking about basically, I'm asking you, where is the graph equal to 0? Where its y values equal to 0? Where is it not equal to 0? Where on this graph are the y values above 0 or below 0? Or at 0 and above it, or at 0 and below it? So that's what I'm asking. And you're just going to give me all of the x values that satisfy those conditions. So keep in mind f of x is the y coordinate. And let's focus on let's focus on 0. So I know since we're comparing to 0, I'm going to just kind of mark this thing off. So I'm going to mark off in green all the points where it's equal to 0. And then I'm going to pick a different color for above 0. I think I'm going to go this light blue that looks almost exactly like green. Let me try the dark blue. Maybe that'll be better. It's above 0 there. It's above 0 here, and then it's going to continue being above 0 way off in that direction, all right? See if I can get this thing out of the way. There we go. And then I'm going to use red for where it's below 0. So the y values are below 0 here and here. here. And remember, the arrow says it's going to go off in that direction forever and ever too. All right, so our goal is to look at these conditions and then give our answers in interval notation. As an intermediate step, it often helps me to make a number line. Now, you don't have to do the number line if you can jump straight to the interval notation for these, but it helps me quite a bit. So I'm going to give you kind of some visual ideas about how to think about this as well. So this first one says f of x equal to 0. So I want to look at my graph and I want to try and put on some blinders so that I am only looking at the portion of my graph that where f of x is equal to 0. So where the y coordinates are equal to 0. And I only see 4 points on there. You see the same 4 points? When we give these answers in interval notation, we're going to give the x values of those 4 points. And since they're just 4 distinct discrete points, we're going to put them in those curly braces. So let me not get ahead of myself. Let's, on this number line, let's draw where those 4 points are. It's at -1 and 2 and 3 and 4. And then I'm going to write my interval notation. Since those are separate individual points, we want them in those curly braces with commas in between. In this class, I am going to insist that when you give me interval notation, that everything is in numerical order from least to greatest. Okay, put them in order. All right, so far so good. Okay. All right, next up is not equal to 0. Let me grab a fresh one of these. Excuse me. Hey, so this got kind of confusing for my second period class today because I didn't explain it ahead of time. So I'm going to do a better job this time. I want you to be able to see my graph and my number line at the same time. So I've got another one over here that I'm going to kind of fold so that you can see both of the same. You see what I did right there? It's now it looks a little different from yours, but it's the same thing. I just folded it so that the number line's right next to it. You guys good with that? Okay. I did that without saying anything second period and like 2 examples in there, like, what are you doing? So, okay, not equal to 0. So visually, I would need to take a really thin pencil and hold it across the x-axis, and then I'd be looking for everything else, right? So as I'm looking at this, in this region here, it's not equal to 0. The y coordinates are not equal to 0 in this region here, agreed? So I'm going to color that in on my number line. This region starts at -infinity and goes up to -1. I'll put the arrow over here. I'm not going to worry about dots or anything right there at -1. We'll come back and do that in a moment. There's another region from -1 to +2. Then there's no 0 coordinates in there either, right? They're both below. It's all below. So I'll go -1 to 2. Looks like another region up here between 2 and 3. And then another one from 3 to 4. And final one from 4 to infinity. So I've got kind of the regions filled out. Then I just need to worry about the actual points themselves. So you guys with me? Give me the universal sign if you need a sec. We good? All right, so let's think about -1. Look at that point on your graph with an x coordinate of -1. What is the y coordinate of that point? 0. Does 0 satisfy this condition? So yeah, so you would agree that if I plug 0 in here, we would get a false statement? Okay, so open dot, just what you said. And probably going to be the same for 2 and 3 and 4, right? Same idea? Open dots. Cool. So we're going to write this out in interval notation. This is going to be the longest answer that we're going to write all day today. Because how many different intervals do we have here? 4? 5? I count 1, 2, 3, 4, 5. We're going to have 5 different intervals. I'm going to write small because I've been running out of space all day. Now, this is important. We always start on, if you start on the left and move to the right, you'll always get it in a numerical order. And again, that's what I expect. So start on the left. Where are we starting here? Air quotes, negative infinity. And do you all remember, does infinity and negative infinity get a square bracket or parenthesis? Always a parenthesis, because you can't actually get there, right? It's not actually included. It's an abstract concept. And this red section here stretches all the way, it ends at -1. So comma -1. -1 is parenthesis square bracket, parenthesis because of the open dot. That's our first interval. Now, when we list intervals, do you remember what we put in between the intervals? It's a symbol, but it kind of looks like a letter. Yeah, like a capital U. It stands for union. And then I'll write my second interval after that. My second one goes from -1 to 2. And those are both open dots, so parentheses. And then union that with the other ones. What else we got? -1 to 2, 2 to 3. Oops, I forgot my U. There's my correction table. Running out of space. You don't like the U? I'm sorry. Do you like the other one? So, do you remember Venn diagrams? So U just means that you're taking a collection of anything that's in any of the groups, right? So in a Venn diagram, that would be the union of the two circles. So that's all it means is my answer is the collection of any point that's in any of these regions. If you flip that U over, you get another symbol that's called an intersection. And that would just be where they overlap. We will not be dealing with this very much. But the U basically, in English, the U means what? Union. And really what it's saying is like also or and, right? It's just kind of like a comma. Like this region and this region and this region and this region and this region. All right. You guys feeling all right? Let's keep going. All right, folding again. Okay. Greater than 0. So this is a big strategy if you start struggling with this, especially when you get to the greater than, less than. It helps me sometimes to block off the portion of the graph I'm not interested. Remember, we're only interested in y, where y coordinates are greater than 0. So we are not interested in any negative y coordinates. We're actually not interested in any coordinates that are on the y-axis either. So when I look at this, I'm already predicting that I'm only going to have 2 regions. Can you visually see those 2 regions there? Okay, so let's just look at the numbers and see where those regions are. One's from 2 to 3, and the other one's from 4 to infinity. And then we'll need to ask ourselves, okay, what's happening at the ends of these, at this 2 and this 3 and this 4? What are the y coordinates at 2 and at 3 and at 4? 0. Does 0 satisfy our condition here? Is 0 greater than 0? No. So we will not include those. Oh, this will be a simpler one. We only have two intervals this time. So go ahead and write that intervals, throw a U in between. I'm sorry. Yeah, there's some back there. All right. Next one, same idea, but this time we're only interested in the y values that are less than 0. So I'm going to take my little note card or whatever, and I'm going to cover up everything that's greater than 0 or equal to 0. And yeah, how many regions are you seeing here? 4. I'm seeing 1 here for sure. And then, are these separate or are they the same? We'll come back to that. It's either 2 or 3 though, right? You think they're separate? That's a great question. Well, there's definitely 1 here from 3 to 4. Let's draw that in. So what I like to do is draw the regions in first and then come back to the points. And then that'll, if the point ends up not being included, then that'll separate the 2 regions. But we definitely have a region from 3 to 4. We definitely got a region here to the left of -1, and we've got another one between -1 and 2. And then we just need to go back and think about what's going on at those endpoints. What's going on at -1, at 2, and at 3. And what is our y coordinate at -1, at 2, and at 3? Well, and 4. They're all zeros. Does 0 satisfy the condition here? It does not, so open dots. So are we seeing now, I feel like I saw the light bulbs come on for several of you. You see now why there's going to be 3 regions here? These 2 are really close together, right? Like they literally could not be any closer together. There is 1 number between them. -1.000001 is in this, and -0.9999999 is in this, but not -1. All right, let's do this. 1, 2, 3 regions. We'll start from the left is -infinity. Gets us up to -1. Parenthesis or bracket. Parenthesis, and then our u, and then we pick up on the other side of -1, so parenthesis, because it's still not included. Up to 2, and then 3 to 4. You guys are doing awesome. Got a couple more to go here. These next 2 are a little tricky. The last one's the weirdest one. All right, so now we're talking about greater than or equal to 0. So when I cover up the parts I'm not interested in negatives, but I want to leave it so I can see where it's equal to 0 as well. So I see, when I look at this, tell me if you agree with me, guys. I'm seeing 2 regions, but then also a little lonely point that's out here all by himself. How do you think? What are we going to put around this little lonely point? Those curly guys, because it's a single spot, right? It's a discrete value, yeah. So let me get set up here. Greater than or equal to 0. So we do have a point at -1. We want that on our number line. We got a region from 2 to 3 and from 4 to infinity. Question? When I say discrete, I may not even be using the technically mathematically correct term. I'm talking about a value that's by itself. It's not part of a region. A region would be like all the numbers from 2 to 4. You know, there are an infinite number of points between 2 and 4, right? So if you've got like a span of numbers, that's a region. But if you've just got that one lonely singular spot out there, that's that discrete point. It's that singular point. Yep. Just the dots. Yep, exactly. Just like that first one, because there were no regions connecting them. They were just those individual points. Yep. You're welcome. Thanks for the question. What about 2, 3, and 4? Open, solid, open, closed? Okay. Well, I think because it's greater than or what is the y value here? Is 0 greater than or equal to 0? Yeah. So we need to include them. So -1's going to get one of these funny sideways mustache brackets. Nice. I'm gonna pause here for a second.
What color is math?
Good question. We'll come back to that. All right, hey, folks, I know it's Friday, we're getting a little chatty. Let's stay on target, okay? Let's stay on target, let's get this done. And then you'll have some time to work and chat with your neighbors at the end of the class here, okay? This last one I'm going to challenge you to do. I'm going to tell you that most people get a correct answer, but there's a better correct answer for this. So see what you can do with the last one. Try it on your own. Work with your partner. Have a little argument with them. If you want me to check your answer and tell you whether you have like a correct answer or the best correct answer, I'd be more than happy to give you that information.
I rhymed.
You did, and it is right. Nice. Well, so here's the tricky part about this, and there's different ways to look at this. And again, there are multiple correct answers to this, but my biggest hint would be when you look at this, how many regions are going to be in our solution here? How many regions are there? There really are only 2 regions. Now it kind of looks like 3, right? But is there any reason that these 2 regions need to be separate? They're completely connected to each other, right? So if I wanted to write the best answer, I would say negative infinity goes all the way through to 2. There's no breaks in that region. So what I would expect to see from a lot of folks would be negative infinity to -1, and -1 to 2, and 3 to 4. And that is correct. That is right. But this is the part that's redundant, right? Why are you stopping at -1 if you're going to include it and pick up right on the other side of it? So let me give you guys, because I told you I'd be transparent about tests and quizzes and stuff. If you were the teacher of this class, and let's say this was a 4-point problem, and someone gave you this answer instead of this answer, how many points would you give them? 3? You guys are tough. You give them 4 for this one? Yeah, but this is better. Okay, so you. All right, so in the interest of transparency, for my class, it'd be 3.5. Yep. Yep. Like small. I mean, obviously, you know what you're doing. It's just, simple. Make it simple. Make it concise. Make it clear. That's that communication piece of math. Someone asked this in a previous class, like, what if I did this interval and I wrote it as infinity, 4 instead? That'd be like a 0.5 point. Like if you flip the order of them and had the bigger number first, I would take off 0.5, but not much. All right, hey folks, can I get you to work on the next one on your own, or with your table partner? Next graph. I'm going to put answers up here so you can check as you go. Give you about I'm going to give you about 7 minutes on this, and then we're going to move on to the back side. I'll put my answers up here so you can check as you go, but try and do as much as you can. This is a great opportunity if you are having any struggles with this to get my attention so I can work through it with you. Right now I have a sketch of it with color coding, and I did put a little hint up on the screen if you want to check that out before you go. It's up to you. My assumption is that if you see a function like negative 2x plus 4, that you can immediately picture pretty accurately what that thing looks like without punching it into your graphing calculator. Okay? That you know that that has a shape of what? Yeah, this is a linear function. You know that it has a shape of a line. Hopefully you're able to look at that and say, oh, it has a negative slope, so it's going downhill. It's going to cross the y-axis at 4 because y equals mx plus b, right? I want to review with you really quickly. Algebraically, to find the x and y intercepts for any function, there is a process, and it's universal no matter what type of function we deal with. Do you guys remember what is the process for finding the y-intercept of any function ever? X equals 0. I really need you to have a strong connection in your head between these two things. F of 0 is the y-intercept for any function. When I ask you to find the y-intercept, I'm asking you to find f of 0. If I ask you to find f of 0, I am asking you to find the y-intercept. Do you see why that is? If x is 0, then that means any point that has an x coordinate of 0 is going to be on the y-axis. It has to be a y-intercept. All right, so if I ask you to find the y-intercept of this function, most of you can probably just look at it and tell me. If I ask you to show your work algebraically for this, this is what I would want to see. I would want you to write down in your work, f of 0 equals negative 2. It was x, but now I'm plugging in 0 because that's what f of 0 means. And then I would write equals 4. And that's it. We are doing an intercept. Intercepts deserve a little bit of recognition because they are points. So we're going to be respectful when we write their names down. Points get written as an ordered pair, x and a y coordinate. Which one is it? Is it 4 comma 0 or 0 comma 4? 0 comma 4. You guys are awesome. There is a universal method for finding the x-intercepts also. Again, any function that we look at, when we start looking at cotangent and secant functions in the second semester, and I ask you to find the x-intercepts, you're going to use this same method. What are you going to do? You're going to set the y equal to 0, and then you usually have to solve. You're not just evaluating, but we're going to set the y equal to 0. So if I asked you to do this for this problem and show your work algebraically, here's what I want to see. I would want to see that you said instead of f of x, 0 equals negative 2x plus 4. You want to put the 0 at the end over here? I'm okay with that. Hey, and I got some great news for some of you that's coming up right now. Your Algebra 2 teachers expected you when solving an equation like this to show your work, right? minus 4 on both sides. Was that still the expectation last year? We have graduated past that in this class. So you can do in your head minus 4 on both sides and just write negative 4 equals negative 2x. Isn't that awesome? You do not have to write, and you don't have to write divide by negative 2 on both sides. You can just know that you're going to result in x. Negative 4 divided by negative 2 is 2. Okay, we have reached that point where we can, I need you to show me your steps, but you don't have to show me those in-between steps where you're showing how you got there. You're more than welcome to. Some of you are still going to choose to do it because you're going to find that it makes you more confident and more accurate, but you don't have to anymore. This is an intercept, so it also deserves an ordered pair. Is it 2 comma 0 or 0 comma 2? 2 comma 0. Awesome. All right, so if we got two intercepts and it's a linear equation, these are pretty easy to graph. That's a line. All right, I'm going to give you a chance in a moment to talk about the intervals, but can we talk about domain and range and increasing, decreasing really quickly? This, again, this is another one of those things that my expectation is that you are experts at looking at a graph and finding domain and range. When I find the domain for this graph, am I looking at X values or Y values? X values. Which X values will end up being on this graph somewhere? All of them will, right? So you could write all real numbers, or you could write it in interval notation. Heads up, I'm telling you right now that your textbook and your test instructions will instruct you to give your answers in interval notation for this whole chapter. Chapter 2, I'll ease back on that, but we are going to ask you to give everything in interval notation. So I would prefer for right now that you write negative infinity to infinity. This right here will lose you points on a test or a quiz in this class. All real numbers, maybe, I'm guessing that's what it is. I see it on papers all the time. This is not mathematical convention. If you can either write out all real numbers, or you can write the accepted symbols for all real numbers, or you can write the interval notation, but this is not mathematical communication. Yeah. This guy right here, the double bar R. Yes. So it's like an R with another. Yeah, I kind of, but technically, usually these are connected if you handwrite them. Yep. Looks like two R's. Do you know the symbol for the integers? It's a double bar Z. That's the all real numbers and then all integers. Anyways, how about range? The range goes with the y coordinates, good. And what y coordinates are going to end up on this graph? All of them. So let's go ARN. No, negative infinity to infinity. This is further down the page on your own page, but increasing. Is this graph increasing anywhere? It is not. So you could say none, or you could give the symbol for the empty set here. The empty set is like a capital O with a line drawn through it. How about decreasing? Negative infinity. It's decreasing everywhere. So if you guys know that when we're doing increasing, decreasing, constant, we're just basically walking on the function from left to right. Are we going uphill? Or are we going downhill? Or are we going flat? Cool. All right, let's look at the second function up here. Again, my hope is that you can look at this function and immediately be able to get a picture of what it's going to look like. What's it going to look like? Oh, you're air drawing it. What's the name for that thing? Parabola. Which way does it open? Opens upwards. Can anybody look at that function and tell me immediately what the y-intercept is going to be? -4. Anybody able to look at that function and do a little mental math and tell me what the x-intercepts are going to be? Nice. And we're all going to get to that point at some point. Right now, I need you to know that it is a parabola because of the x squared. Shh, guys, stick with me a sec. It is a parabola because of the x squared. It is opens up because of the positive coefficient. And if you're not sure about x-intercepts and y-intercepts, you need to be confident and quick in just saying, okay, I'm not sure what the y-intercept is, so I'm going to do f of 0 because that is the y-intercept. F of 0 is the y-intercept. In this case, it would be 0 squared minus 4, which is, oh my gosh, it's -4. And of course, we'll write that as 0, -4. And if you're not confident looking at this and just knowing what the x-intercepts are, you know how to find the x-intercepts. You're going to let y equal 0. So you're going to rewrite this with a 0 out here. There is another form of this function that I would really want you guys to be able to pull off and write quickly as well. X squared minus 4. Could you factor that like in a matter of seconds? Oh, good for you. Good for you. This is called a difference of squares. If If that's not immediately familiar to you, please write down those words, difference of squares. Take 5 minutes this weekend, do a little YouTube search. You'll get it back quickly. We're going to be practicing that on our assignment today. So to find my x-intercepts, I'm going to set which one equal to 0, the original or the new? The original or factored? Which would you choose? Original. 0 equals x squared minus 4, and then solve it. Plus 4 on both sides gets us 4 equals x squared. Square root both sides. Remembering that when we square root both sides, solving an equation, what do we not forget to do? Plus or minus. Plus or minus 2 equals x. Could we have used the factored version to do this? Heck yeah. 0 equals x plus. Let me show you what I would want to see on your test or on your homework if I asked you to show work for this. You would use your 0 product property to split it up and set both parts equal to 0. Do you guys remember doing that from algebra 1? And then we could solve it, and we no longer have to write minus 2 on both sides. We just go x equals -2 and x equals +2. However we end up there, we're going to get 2, 0 and -2, 0. So that whole process right there, you look at x squared minus 4, I need you to be able to think about, okay, what other forms could I write this in? What are my x-intercepts, y-intercepts? What's it going to look like? And be able to work through that stuff pretty quickly, because like I told you on Wednesday, this isn't about knowing facts, it's about knowing when to use facts and how to pull them together in this course. Let's graph this thing. We got a y-intercept, a couple x-intercepts. And we're gonna kind of leave it here. I want to tell you again, let me give you an example of how we're going to use this next week, just so we see where we're going, okay? Next week, I'm going to give you a function that looks something like f of x equals the square root of x squared minus 4 over x squared minus 3x plus 10. Okay. And as one small part of your problem, you're going to look at this x squared minus 4, right? And you're going to think to yourself, first, a little preview here. What has to be true about what's inside of a square root? What kind of numbers can we put into a square root? Positive. Can it be 0 also? Yeah. So would you agree that in order to make this thing work, we got to have x squared minus 4 greater than or equal to 0? So I need you to be able to look at that and then be able to picture, oh, x squared minus 4 is just a parabola. It's opening up. It's got a y-intercept down here. It's got these two x-intercepts. Where is it greater than or equal to 0? Oh, it's greater than or equal to 0 here and here. So this part of my domain is from -infinity to -2 and from 2 to infinity. That'll be just one step in solving this problem, okay? That's where we got to go, and that's why we're reviewing this stuff, okay? Now, do I expect you to be as quick as I just did it, like on next Wednesday? Obviously not, but that's where we're going, okay? And that's why we're kind of reviewing this stuff now. All right, you guys did awesome today. I'm going to put my answers to the bottom piece down here. If you feel like it would be good for you to practice a little bit more interval notation stuff, then go ahead and do it. Otherwise, you may start on the assignment. Give me a second here, folks. I want to show you what the assignment is because it's complicated. I will check homework. Yep.